All right, our next example, we're going to have r equals 2 sine 3 theta. Well, it's not a cardioid, but maybe it's a rose. And I would like you to guess how many leaves you think it's going to have. All right, so remember, first off, when is r bigger than 0? Because there's special directions if it's negative. So what we're going to do, we basically just want to know when is sign positive, right? All right, we know that sine is positive in this region and in this region, that quadrant and that quadrant. If we wanted to label them, so it's positive in 1 and 2. All right, now we need to find our auxiliary lines. So we know the first quadrant is between 0 and pi over 2. However, there's that pesky 3 there, so let's divide by 3 on all sides. When we do, we get pi over 6, excuse me. We get pi over 6. So our auxiliary lines are going to be every pi over 6. So when we go to graph this, we're going to have our 0 line, our pi over 6 line, our pi over 3 line, our pi over 2 line. I'm just adding pi over 6 every time. Our 2 pi over 3 line, 5 pi over 6. This is pi. 7 pi over 6. 4 pi over 3. 3 pi over 2. 5 pi over 3. And 11 pi over 6. There we are. Okay, now we have to figure out where the quadrants are. So this is 1. This one gets converted to quadrant 2, quadrant 3, quadrant 4, quadrant 1, 2, 3, 4, 1, 2, 3, 4. Okay, we got to remember sine is positive in quadrants 1 and 2. Now let's make our theta R chart, and maybe we can find some patterns. Start at 0, pi over 6, pi over 3, pi over 2. Okay, and then we're going to continue on. Two pi over 3, 5 pi over 6, pi, 7 pi over 6, so on and so forth. Okay, when we substitute in, we get 0, which is just pi over 2, so that's 2 times 1. We get 2. See, that's exactly why we found our auxiliary lines. So when we apply the trig functions, we get really nice things. I think you guys can guess the next one. It's multiplying. Get negative 2. We get 0. We get 2 again. 0, negative 2. And it just keeps on going in this pattern, alternating between 0, 2, and negative 2. All right. We got to keep in mind which quadrant sine is positive. So in quadrant 1, sine is positive. At 0, we're at 0. At pi over 6, we go out 2. We're positive that whole way. And then from 2, we got to go back to the origin, and in quadrant 2, sine is positive. All right, and then we're in quadrant 3. Let me highlight it. Quadrant 3 here, and that's going to get reflected across the origin, and it's going to go over here. If you're having trouble seeing which one gets reflected to what, you can always think of this line gets reflected to this line. This line gets reflected to this line, and so on, okay? So we got our orange, we're starting at 0, then we got to go out -2. Normally it'd be up here, but it's -2, so we have to reflect it. And there we are. Okay, and then the next quadrant, quadrant 4, sine is also negative. So this quadrant gets reflected down to this quadrant. And here we are, we're down here at this point, we've got to go back to the origin. Okay, then in quadrant 1, sine is positive again. So we start at 0 and then go out to 2, continuing the pattern. And then from 2, sine is still positive, and then we go back to the origin. All right, then we're back at 3, quadrant 3. We have sine is negative here, so it's going to get reflected over here. But look, we already have that. We already drew that once. So we already have that part of the petal. And then in quadrant 4, continuing around, we're at this quadrant, gets reflected to this quadrant, and we already drew that. So you can see that we're going to continue on with this pattern and see that we just draw over this rows twice if we go from 0 to 2 pi. So, in fact, we just get a 3-leafed rows. There we go. So, the homework will be over this stuff, and then next time we're going to get into derivatives and finding the slope of the derivatives. All right.